And we should be live. I'll wait until the stream confirms that, because audio is always a pain. Come on, stream. 30 seconds delay is huge. Yep, but it works. Okay, so there's audio on the stream. And so today I wanted to do something a bit relaxing. I have to clear my mind because the whole week, including the weekend, I worked on releasing the video, and I actually released my episode. Let's clean this. I just released my episode a few hours ago on my website, actually, qvoodoo.info. It's not on YouTube yet, at least it's not listed. For that, I always wait a couple of hours. So if there's a mistake or an error, then I can fix it before I publish it on YouTube, because there you cannot change everything. So yeah, you can watch the video on the on my website, or you wait a couple of hours and it will be on YouTube too. But today, so yeah, something relaxing now. For some light in my bedroom, which I won't show you, you have because I don't have any mobile camera, but I'm using LED strips for illumination, RGB LED strips, and until now I use that for controlling it. And the problem is always switching on and off using the remote is kind of a pain. I want something a lot more easy. I also have a switch where I just can switch on and switch off. And still I have to look for it. I want it to only illuminate when I'm moving. And that's why we will make a combination, but I need to find the material. Everything has been cleaned. So let me check if I still have some LED strip where I can show it. No, not this one. No, these are just reels. These are addressable LED strips. These are addressable LED strips. What's this? Double-sided natural white. Let me check. Ah, cop strips. I forgot about them. Oh, I don't have any? That's not possible. I don't have any RGB strips anymore? Nah. Yes, addressable. Addressable. What's this? Addressable. Addressable. These are the... Damn it. Okay. Ah, I know what I can use. I think one of these is an LED. Yes. Okay. But I don't have any non-addressable LED strips anymore. Well, I have some, but they are not RGB. They are RGBW. And for now, we're just working with RGB. So for that, we will use this. That's actually an RGB strip, 12 volt. But it's in a silicone form, so it can. It's a sort of neon replacement with LEDs. So you have the strips. You have the strip on the side going all along, and then you have a diffuser, which kind of should make it look like a neon strip. Let's try it out actually, and I'll show you how it looks like. Up my bench 12 volts. I'm not sure if this is, it should be sufficient. Yes, it is. And it looks like this. And yeah, this controller is pretty small, and you can control it just using a remote. So yeah, we have an LED strip on which we can try it on, because the one which is in my bedroom isn't detachable. It's fixed. And what I want to do is don't have any manual control anymore, but have some motion control. And for that I will use too many strips. I love light. So let's dim the luminosity of this one. Doesn't it work? Can't I reduce the luminosity? Can switch it off. Okay, there's no less luminosity. That's weird. Okay, that only works when we don't fade. When you fade, it's full luminosity. Yeah, stupid microcontroller. But I want to use these kinds of things. These are motion control LEDs, and motion control LEDs. Normally, you have to power them with AAA batteries, AAA batteries. Let's get some AAA batteries. Oh, I need 3 of them. 3 of them, yeah, because they don't want any boost circuit, and generally you want to work with 3.3 volts, or between 3.3 volt and 5 volts, or between 3 volts and 5 volts. This is why these gadgets often use 3 batteries, which are 1.2 volt or 1.5 volts nominal, and 3 of them makes between 3 volts and 4.5 volts, so it's perfect for microcontrollers without having to need an LDO or something like that. I will see what's inside. Actually, I don't know. So this is how it looks like now. It doesn't work because here is a passive infrared sensor, a PIR sensor, motion controller. This is just a button, and currently it doesn't work because it's too bright. It only works at night. But if I put it on, I think you can. Yeah, you can see it briefly, and that's an RGB LED. This is the LED inside. I don't know why I'd have that. Yeah, I did already something where I combined 2 of them together. So let's have a look at which one do I want to use. Let's have a look at inside, what's inside. I don't need this anymore. They should be pretty similar. One just looks nicer than the other, but I'll just use the one which is easier to drive. So the issue is that here we have RGB LEDs, which are individual, which are normal RGB LEDs, not 12 volts. And I want to change the circuit to actually work with 12 volts. So if there is no voltage regulator, I will need to add one linear dropout, probably, because this will not operate at 12 volts. And I don't want to have batteries and change the batteries all the time, because I have 12 volts. Oh, this is okay. This is integrated. No, okay. But this is very simple circuit. And normally it fades. So, what's this? They're actually using an LED as, because that's not expensive. But I thought they was using a CDS. This is photoresistor, but they're really using the. So this is the. Let's zoom a tiny bit up. So this is the infrared sensor, and you generally need some kind, which is here, this kind of lens. So it creates a pattern and spread it. So this works correctly. This is the button, and this is the light sensor. And they're using an LED as light sensor. Normally, I've seen them with light resistors, with photoresistors, but not with LEDs. And we have one chip which does everything. This. When I zoom, I have to move a tiny bit the camera to the edge. Okay. And here we have the microcontroller, which handles everything. And as expected, there's no marking. It might be a microcontroller which is really just meant for that. But is there a voltage regulator? Yes, there is. I think this is a voltage regulator. This tiny thing here, because it takes voltage in. This is the plus. Yes, this is the plus. So the plus goes here through this line, and probably this is the voltage regulator. We'll probe it with the multimeter, and we have a decoupling capacitor just next to the voltage to this chip. So it's very probably a voltage regulator. We even have a second one possibly, but it's not populated because they want to not be too expensive. so they want to save money, and apparently it works without. And yeah, the issue is that these things drive the LED directly. And here we have resistors which actually set the value of the RGB LEDs, but why only 2 resistors and why not 3? Oh, is this a third one? Why is this one larger? Here we have 2 small resistors, which 06, 03 probably, and then we have this 1206. But this seems to be the third one. And they are probably common cathode. Common anode, so you can switch them by pulling low. But we will check that either with the multimeter. Yeah, let's go into diode mode. And I expect it to be common anode. Let's see. Oh no, maybe it's the other way around. Plus might be here. Plus might be here and minus here. Okay, so it's none of the 2 options. That's kind of weird. Here. Okay. So this does the red light. You can see it properly, but yeah. This is the red light. But I don't know why it doesn't. Maybe this way. Okay. So this is the common anode, and the other pins are the cathodes of the individual LEDs. Yeah. Exactly. So it's a common anode LED, and it's probably the same here. That might be a common anode LED, but which is kind of good because this is also common anode, and then we switch for the anodes. But now let me think. Normally we need this is to drive the LEDs directly. We won't be able to sync the 12 volts directly from these LED strips, so we will need to add a MOSFET. So either we reuse this circuit, and this circuit can be I might make a combination with this circuit and this one in parallel, and if this one doesn't drive the LEDs, this one can drive the MOSFET. That might be some possibility. So but it fades. How does it do the fading? Does it do the fading with current syncing, or with, which I doubt, or with PWM? It might be streaming. Playback, Chrome, you go to this one. So the stream should work again. Let's wait until I hear my voice. Yeah, so I'm back. So for I don't know which reason, when I switched on my oscilloscope, it crashed the whole USB stack of my computer, and I had to completely restart it. That was the easiest, and then you have to restart the audio also, but I'm back. And the oscilloscope is started, but the rest is not finished yet, so let me finish this. So this is the screen for the dashboard, and I have to connect to the devices which are on the dashboard. So now we should have values for the multimeters. That's okay. Now values for the parameter, the power supply. Okay, that works too. And now let's get information about the oscilloscope. OSCI capture. How did this work? The IP of the oscilloscope, I don't remember. And it's only over network. Oh, but I know where I can find it, because it's a static IP, or at least a static lease. So, what's UIP oscilloscope? Mm-hmm. 130. Command not found. Yeah, it's oscilloscope and then the IP. Capturing, continuously capturing display. It seems to work. Do I have pictures for that data? OSCI captures PNG. Yes. And now let's show the capture. Is it this one? Yes, it is. And I have to auto refresh. How did this work? I have an auto refresh script normally. Don't I have it anymore? Extensions. Auto refresh. Auto refresh is here. Let me make it auto refresh. Here. That's a WebSocket client. It's randomizer. Where is the auto refresh button? Oh, it's not activated. Okay, now it's activated. Auto refresh up every 2 seconds. Okay. Yep. Now it should be refreshing. Let's move it back to here. And now you also see the oscilloscope screen. Yep, and it seems to be refreshing. The auto symbol is working. So let's have a look at if it uses current limiting or PVM. It's current limiting because that costs too much, and PVM is a lot easier. But we'll have to be sure about that. I don't need channel 2. I only need channel 1. 1 volt peak to peak, it's okay. Bandwidth limited, that's okay. And I need a power supply. So power supply with the correct leads. And these are not the one I'm looking for. I want the one with the crocodile clips. It's these ones, and while we connect it, set the voltage to 4 volts. Up. 4 volts, and let's set the limit to 100 milliamp. That should be plenty sufficient. I expect less, but 100 milliamp should be fine. 4 volts, 100 milliamp. Let's connect. This is minus. Yep, it is. This is plus is this one. Now we can connect on the back. Connect on these leads, and if I switch on the power, you should also see it on the screen. Yes, 3 volts. And if I cover this, then we should even see the motion sensor reacting. Let's have some tape, some black tape, and try to cover the LED and see if it works. So it shows, whoa. Okay, but that's expected. This is a very, very low power circuit. You see that I'm providing 4 volts and it shows less than 1 milliamp power consumption, which is what you want. You want microamps of power consumption. It would be interesting to know how much it draws in this mode. Let's see. I have a power meter which I've never used until now. Well, I have 2 of them. So if you want to measure power with devices which... When I want to measure low power with devices when I enable it, I use this power profiler kit. It's really good. I can recommend it. It can go very low, and you can have graphs over time, so you can with high accuracy. But I also have this one which I've never used yet, and we'll try to use it actually. So normally you can measure, I could even, I could use the multimeter. That should be plenty sufficient. But I want to use this because I've never used it. I've been gifted it. And it looks nice. It's a current ranger. Seems nice. And it transforms very low current into voltage. So this is the load. This is the output, which you could put to your multimeter. And you even have a screen. Let's switch it on. I don't know why sometimes okay, milliamp. Okay, battery. Is there voltage going out of that? Let's measure the current with the multimeter first, just to have a rough... Let's go into milliamp mode to have a rough idea of how much it uses. Should also see milliamp, microamp. This is the milliamp range, and if we go in between, tick, 1, and let's get another crocodile clip. We should see how much it uses. And this is particularly good for like microamp, very low microamp and nanoamp resolution. And here we see, it uses 40 microamps apparently when it is sleeping. I expected a tiny bit less than 40 microamps. I expected in the low 10 microamps range, but that doesn't seem to be the case. Let's try to see if it works with this device, because I did not use it. So we need, we can directly connect that. So we'll have everything inline actually. Plus, minus. I think it doesn't provide any power. Load, I think you need to provide power. This is to measure. How can you provide power? So let's use the second multimeter and see if it actually provides any voltage. Up, volts. Check. No voltage, and the battery on this multimeter is dead. Let's put it to charge. It's not a problem if it's connected. You are charging. Oh, okay, it is a problem. See, I can't use it now. So there's no voltage. So how do I enable the voltage on this thing? Do I have to press a second time? That's so the battery voltage is 4 volts, so that's plenty fine. Ah, the case is broken. That's a shame. But yeah, it's still holding. USB, this is to charge. Let me switch on the power. How does this work? I have to press 2 times on the button. Ah, here. Something like that, no. This is auto. I don't want auto. I want by hand. And I want you to power the device. Source load. Ah, so it can't power. It can only measure. It's an inline device. It cannot power. Apparently source plus. So that's the power, and then it goes to the load. So it's like a multimeter actually, but with very low range. I thought it could provide power bias. Low pass filter. Oh. Okay, bias. What's bias? No, that's not it. Okay, this switches on and off the low pass filter. And this switches, okay. That's not, I don't know who designed it, but the 2 buttons on the right switch on and off the bias, and the 2 buttons on the left switch on the low pass filter. Nah, could have done better. Yeah, could be the other way around. Maybe, I don't know if it's intended, but it's weird. Okay, so it cannot power. It has its own power source to work, but it cannot power directly. Well, so let's use the power supply. So the power supply plus, you go into here, then the power supply minus goes here, but the plus, this goes to the load. Okay, so yeah, same thing. 40, whoop. And it has a USB interface, so you can actually log. I don't know how fast it goes. So yeah, 40 milliamps. So it's yeah, it's okay. It works, but the multimeter does the same job. Still, that's nice. It's probably better when you connect it over USB or when you really measure into the nanoamps range. Let's put this multimeter to charge. Okay, this is charging. It's weird. Even if it's when it is charging, maybe it's charging slowly. Yeah, well, multimeter is charging. So yeah, this device works, but it draws 2 seconds off. It draws 40 milliamps, 40 microamps when it is sleeping. With batteries, I think it holds 2 weeks or something like that. Easily 2 weeks, probably a month. When I use it with the 3 batteries, and then in the evening I have one in my floor, and I'm fine with it actually, with the longevity, so that's okay. So yeah, we wanted to check if it actually uses PWM to drive the LEDs, and first for that we will have to activate it. So let's simulate darkness by putting this LED. Almost. Yeah, no, not completely. Now we have the red LED, which is on, and normally it should be fading. And normally, yeah, this should be fading. It's really sensitive. Okay, now it should be on. And yes, this is fading, and then we have the 3 RGB colors. So it's nice, so surprising that they managed to do it. And when, yeah, you see when the LED is powered, we are drawing 30 milliamps. This is normal because we have generally around 10 to 20 milliamps per LED, and not all LEDs are on at the same time. but yeah, not all LEDs are on at the same time. So because we have two colors or changing colors. So let's check. This is one of the values. And it is at 3 volts, but it is not going down. So it's not... no. Here. Yeah, PWM. You see on the oscilloscope, it works. You should also be able to see it. Now the blue is completely on. I think I touched the blue channel. Let's wait until the next one comes. And this, let's check. Let's change the trigger source on the oscilloscope. Yeah, now it's a lot more visible. Up. And the trigger points, let's move it around. It's not, I use the probe on the negative and then I'm probing also the negative, so it doesn't work that well. And I'm using it after the resistor. But yeah, it works, and we see it uses PWM. Show me the PWM signal again. Come on. Is this LED completely? No, there's something wrong here. Try with another LED. That's red. Now it's changing color, but the probe doesn't show me the PWM signal. Now it does. So it's probably another channel, and they are only PWMing one channel at a time. But they're using PWM, which is actually good because we can use it to drive MOSFETs. And I think this is what I'll do. I'll drive MOSFETs to switch on and off the 12 volts. This can't switch on 12 volts. This is only for 3.3 volts. And actually we can also measure if it uses voltage regulator, and the voltage regulator, is it also used for the LEDs? I don't think so. That would be a waste of energy. I think it's only used for the microcontroller, so it has some stability. So this is plus, this is ground. Yeah, let's clip the ground. Up, ground. Let's clip it here. Check. So this is the input. This should be 4 volt. I'm not creating a short now. I hope I didn't blow the fuse. No, I didn't. It's 1 ampere max, and I set the limit to 100 milliamperes. So volts. Oh, this is highly sensitive to light. Amazing how they could use the LED to sense the light. So here we have 4 volt inputs. Let's see on the LEDs we have a common, so we have here the common anode, which is also at 4 volts, so it takes directly the input of the battery. Here we have the input of the voltage regulator, which I think is the voltage regulator. This should be ground, so here we have 0 volts, and this pin should be the output 3 volts. Okay, 3 volt voltage regulator instead of 3.3, why not? Maybe but then it wastes even more energy. I don't know why they use 3 volt voltage regulator. But yeah, they use a 3 volt voltage regulator, and we could actually measure it on the pin. Maybe it's required for the passive infrared sensor, which needs to be operated at 3 volts, and then the microcontroller is fine with the 3 volts. That might be the case. And here we can see, it also bias, so it provides 3 volts to the LED, to the photodiode, and it probably then measures how much current goes through it, or what the resistance is. PWMs, it syncs, meaning that we have to use PMOS. No, NMOS. No, PMOS. Actually, if we use... It syncs individually, so it pulls low to enable it. Pulling low to enable something, this is clearly an PMOS task, but we will use NMOS because we also are switching the cathode of the LED strip. But what happens if we let the... And actually it syncs. So it doesn't drive, it only syncs. So what we could do is have the MOSFETs always on, always high, and then let it sync. Can it... Yeah, let's test it. So can it sync, or does it actually put a voltage? Is it operating in sync? Yeah. Is it operating only as sync, or is it also pulling high? No, it doesn't, because we don't know what the input voltage is, so it really is only syncing. Yeah, but it will never be able to sync 12 volts, or at least the amperes on that, so we'll have to put something in between. But it can only pull low, it cannot push, it very probably can't push high. We can test that. So let's enable the soldering iron, and let's test if it can actually also push. Oh, I see that the video quality is not always too good. Yeah, don't know why. So let's connect that again, and this is one channel. And right now it is not on. Now it is on, but it's only red, and the red is the other side. So this is probably green or blue. Let's wait until it shows up, and then yeah, it doesn't go. So here we have the 3 volt. Why do I have 3 volts? We should have 4 volts from the no, 4 volts from the LED plus the dropout 4 volts from the power pack, power supply, and then 1 volt for the LED. Oh, the video is quite lagging. I don't know why though. Because it's using the network. I know why. I'm using the wrong network. Let's make it this way. Maybe it will be disconnected for a short while, but I'll be back soon. So we should be back, and the video should be a lot better now. And the issue was that currently I was using the network card which is on my USB hub, and this was using too much bandwidth, meaning that it was using up the bandwidth from the USB webcam, or USB capture camera, HDMI grabber. This is why it didn't work too well, but now I'm using the network port, and I shouldn't use any network resource. I shouldn't use the USB resources, and yes, it's a lot better. Yep, I forgot about this aspect, the networking aspect, that it uses bandwidth. So yeah, let's continue. Here, the LED. Why don't you change color? Did I press on a button? So normally sometimes the button is there to change the mode. Now it does change color. We have yellow. Okay. and now I don't know which color it is, but now we see that it pulls and we don't go to 0 because we have a resistor which uses the last of the current. On the multimeter you should also see it. Does it not grab? No, stopping captures. Let's restart the capture because I restarted the network. And this font should also be a bit smaller because it uses too much screen. Come on. Up. Let's fix that. Home automation, a lot of things to fix, but yeah, this is a stream, this is relaxed. It's not like a video, it doesn't have to be too professional. And this way you can see that nothing is really too easy. Bench. Up. Headline. So let's change the font size for this thing. Done. Deploy. You should connect again. Measure. Still too large. 8. Done. Deploy. Up, up. But it doesn't change anything. Font size 6. Do I have to put points? Deploy. Okay, it will just not work. Okay, I have to put point on it. 6 is too small. Let's put 10 back. Done. This one we can put 6 point also done. Deploy. And up. Okay, 10 is too much. Let's put back 8. Done. Deploy. And this interface I'm actually using Node-RED for showing you the measurements. I think I already did a video about that, how my network is, or I put it in the wiki somewhere, I don't remember exactly. 8 is still too much. Let's put 7. Done. Deploy. If 7 doesn't work, we'll put 6. Measurements, and these are just Node-RED dashboards. So I'm using MQTT to send the real-time values. So I have scripts which grab the values from the multimeter and from the power supply and then send it over MQTT to my broker, which is Mosquitto, I think. Yeah, it's Mosquitto. And then Node-RED just gets the value from the broker. And there is the plugin for the dashboards. This is what you see right there. And it's still too much, so it's 6, and I hope that 6 will be fine. And still visible, because previously the values weren't really readable. Now it is readable. It's okay readable. Auto. Yeah, it's okay readable. Up. And measurements also here, auto. I don't have to put 60. Up. Last thing. Okay. Previously I had the values right here, meant that they were really too small. now they're a bit more readable, at least for the stream. This header should be, can't I remove this header? What's this? No, this is F11. It would be nice to somehow be able to remove this header where I don't use it. But here we have the PVM. You don't see it as good as on the oscilloscope because the refresh rate is only 2 seconds, but here we have the PVM signal. So we have that. Can it drive? So for that, we will just have to measure. So this is now fully on. If I desolder tweezers, if I desolder the pin, we will see that if it's high or not. Because then we can test if it's syncing. Yeah, I'm doing it while it's live. And this was blue, actually. Now let's measure this. Oh. Yes. I didn't expect that. I really thought it would only sync and not source, but it can really drive high, because here we see also the PVM signal, although there is no power coming in through the LED. So that's a good thing, meaning we can actually drive the MOSFETs. The problem is that we have to invert the circuit somehow, because normally, so this switches, this puts low to switch on, and on N-channel MOSFETs you switch high to switch on, and we just have to invert the circuit. We could also really just design our own and so on, but I wanted to hack the device, to hack this device and see if it's possible to reuse it instead of having to do the thing again. What happens if we provide 12 volts? Because does the LDO work? And if it breaks, it's not matter. The problem if I provide 12 volts is that the LED will get grilled, because it provides power to the LED directly. So let's cut off the 12 volts from the LEDs. Let's switch this off, and let's see if it still works with the LED broken away. And we will just also unsolder this. I have to put which one is ground, which one, this is plus, this is ground. Let's mark it with a black pen. And this wire is ground. It's also readable on the PCB, because on the PCB it's connected to the large surface. So we could also know it's ground this way. Up. Let's disconnect the LEDs. 2, 3, and I'll keep the RGB LED, I don't know what for. But it's a free RGB LED with a sleeve. And that's the whole circuit. So, can it work with 12 volts without being grilled? Let's put the limit to 30 milliamps. Switch it on. And normally, so now it's still at 4 volts. And now we should still see, come on, connect to the minus. We should still see the PVM signal on the pins. Yeah, it's at 3 volts. Although, and here again, we have removed the complete power from this device. This is where the LED power was, and we still have 3 volts on the oscilloscope. And at some point, it should drive it low, but we don't have any feedback now. Now that's kind of an issue. Is it low on any other? This one is low, and then we have a PVM. And it goes, yeah, it should have ticked me, because it goes between 0 volt and whatever was. and 3 volts. And 3 volts is actually the one provided by the microcontroller and not the one from the LED. So this should have given me a clue. And let's try if it works. So here we have the PWM. So yeah, the PWM is always changing. Let's put the other channels. So normally we should have at least 2 signals. We can see the other ones. Let's switch to second channel. Tac. No. 1 volt. Up, bandwidth limited. That's okay. I will not connect the ground probe. It will be noisy, but oh, okay. Let's connect the ground probe. It's in the way. Up. So now, yeah, and now none of them. Why isn't the other one showing anything? The blue one should also be at some point PWM'd. Okay, now it is PWM'd. So now we have two values. Can I make the refresh rate a bit faster for you? No, 2 seconds is okay. You can see what's happening. Okay, let's try to see if it works with 12 volts. It doesn't use a lot of power. It uses, particularly if it's not driving the LEDs, and it's not syncing anything, it shouldn't be using a lot of power. So the LDO, even if it has 12 volts, shouldn't get too hot, even if everything goes through the LDO. Does everything go through the LDO? Let me check. Yes, except the LEDs, everything goes through the LDO. Let's measure actually if any other points on the board is at something else than 3 volts. Particularly, so this is the LED, the photodiode, 3 volts. And the PIR is weird volt, 3 volts. Okay. And the microcontroller is also 3 volts. I see the trace going there. 3 volts. Okay. And now, well, let's ramp up the voltage and see if the circuit still works. Volts. We are now at 5 volts. The circuit still works. 6 volts. 7. 8. 9. 10. Okay, now I don't know if it doesn't work or if it's just a PWM which has issues. It still draws only 1 milliamp. Okay, it still works. We see the PWM signal. Let's go to 11. Okay, there's an issue here. 10 volt is fine, but you see, when I go above, then it also goes, so it's not able to the LDO. I didn't know that from LDOs, but I also never tried it out. Let's try to tap on something and then see the voltage output of the LDO. Tac. I think this pin is at 3 volts. Yeah, that's the output of the LDO. Okay. We already see we have an output at 3.2 volts. So the LDO isn't able to cope with that. If we switch the voltage, yeah, it goes only up to 9 volts. So 9 volts, it's still regulated 3 volts. Then we go higher, 9.3, 9.4. Now it already starts 9.5. Now it goes higher, 9.8, 10 volts. At 10 volts, I'm already at 10 volt input. I'm already at 3.1 volt output. And then it goes, and it increases. And every voltage adds directly to 0.1 volts. So it can only handle until something at 9 volts, 9.7 volts. It doesn't go up to 10 volts. But we might have a microcontroller, we might have an LDO which is capable of that. Let me look at what LDOs I have and their pinouts. we might just have to change the LDO and then it might work. So this LDO is not able to do it, to handle voltages to above 9 volts. Yeah, as I said, we could create the circuit ourselves. It wouldn't. Oh, the camera is broken, so you don't see what I'm. No, actually, it's not broken. It's fine. So yeah, we could design our own circuits. I wanted to hack a device, so I can figure out how it works and so on. So my data sheets, I have one of these voltage regulator in this form factor. So this is a SOT23. Okay. USB had a bug, but I did nothing wrong this time. Why did USB have a bug? And it's on. Oh, yeah. Is it only USB? Come on, USB. Removing interface. Yep, the USB stack crashed again. I had to restart the whole USB. But I'm back. This time I only didn't have to start the complete computer. The USB was fine by itself. But we are back. Yeah, my USB hubs and my USB stack are not good. I'm working on that slowly. I'm not doing too many streams, so it's not too crucial for me. It's not my livelihood. So, datasheets, let's come back. And datasheets, and yes, I had one of these XC. Where is it? LGO. It's this one. Oh, it's even better. I didn't. Let me show you. It's full screen. Now you have audio. Yep, this screen didn't have any audio. So as I said, this is my this is where my inventory, where I have all my devices. LDOs. What kind of LDOs do I have? Yes, the AMS, but they are not in the right package. They are 233. Oh, these ones, but it's 5-volt output. That's not good. 1.3 volts, 3 volts. This might be fine. 300 milliamp RT. Do I have distributor? Yeah. Let's check its data sheet. This one has the no, it's not the right form factor. It's didn't I? No. Yep, it's not the right form factor. I also have this one actually. What's the distributor? Again, CSC. Let's check this data sheet and see. Yep, this is the right form factor, but what is its maximum voltage? 30 volts? Seriously? I would have expected 30 volts. Wow. Why do I have these things? I don't remember why I have these ones. Up to high input voltage, up to 30 volts, yeah. Fixed output, yeah, we have a 3.3 volt output instead of a 3 volts. I think the microcontroller will also work with 3.3 volts. And the output, the pinout is okay. I remember it for the circuit, and this is the most common one. So we can actually try. How do I have many of these ones? Let's check. I have 100 pieces. Okay. I didn't remember them. Where they are in the PowerBook. Okay, so my PowerBook MOSFET LED diodes power up. let's switch to the bench. This is my PowerBook, and the camera isn't working anymore. Up. Let me switch on the camera and I'll be this. Yeah, I really have to fix my USB setup if I want to stream professionally. Let's keep the cat here. So yeah, my PowerBook with lots of SMT devices, and we are looking for this one, 3.3 volts. Up, and let's change it on the board. Up, up. Let's disconnect the voltage while we are soldering up it. So we have to unsolder the first one and solder the other one. We only want one of these. I can put it back in the book. Yeah, I have 100 of them, so it's not an issue. Up, part is removed. And let's put the new part in. Do we need some fresh solder? Probably. It's not holding. Let me get something to hold the board. Yep. Okay, now it's refreshed. Could also add just some solder flex, but solder also does the job. So is it? Yes, it's the same pinout. It's a very common pinout. I think the voltage regulators, they don't really want to make different pinouts. They want to be most compatible because the market is too large. And if you're not standard, like, you will remove yourself from the huge market. While on MOSFETs, it's not the case. And on other devices, it's not the case. It's not always the case. So let's try again. This connects to minus, which here. Minus is this one. Tack. Here we have. We only need the multimeter for now. We don't care about the. Yeah, I can actually connect on this lead. We don't care about the waveform. Makes it easier to clip. But the multimeter, that's ground. Oh, wrong one. This is ground, and VCC is this one. That's VCC. And if I now, let's try with a low voltage first. Let's try something around 4 volts. 3.3 volt output, that's fine. And if I go up now, 9 volts, okay. 10 volt, this is where the other one had issues. 11 volts, it holds. 12 volts, let's go up to 13 volts. No, that's fine. And even if it draws, even if it's not efficient, I have no issues. And let's test if the PWM works. Because we are now operating at 3.3 volts. This has been designed for 3 volts. So let's see if it works. 1, 2, I think it will work. I think the circuit is not that. I don't think that the circuit is that sensitive. to the parts. Okay. But we have some weird output. The output is at 1.5 volts instead of being at 3 volts. Did I break the microcontroller? Maybe it's just because it's off, and when it's off it's not driving anything. No, okay, now it works. And yes, it's 3.3 volts and it works. We have the first PWM, and then at some point we should have the second one also. Let's wait a tiny bit until we have the second PWM signal to be sure that everything works. Okay, we don't have the PWM or the other signal. Maybe it comes after this cycle. Nope. This channel seems to be dead. But that would be weird, having one channel which doesn't work while the others do. Come on, motion sensor. Do your job. Sense motion. Okay. Why isn't the second output working? Maybe the connection is wrong? It shouldn't be. Blue line. Please do something, blue line. Maybe the blue line is really only syncing. Let's try the last one. That would be weird, having some pins which are syncing and some others which are... No, it's not this one, because we've seen previously that... Oh, it's very sensitive to light. We had a blue. It's just a wrong contact. That's on this one. That worked. Now let's check on this one. But the blue shouldn't be at 0. 0 is always on. It should be at 3.3 volts when it's not switching on the voltage. Here on this one it did work at some point. Where's the motion sensor? Maybe we need to add... that's super high impedance if I touch the probe. So when it is off, it is going to super high impedance, because when I touch the probe, I can inject voltage. Huh? Why am I injecting this square wave? I don't know where this square wave comes from. Is the microcontroller stuck? No, now it's stuck in a color. Okay. Now it works. Okay, it was just in a mode where I didn't select the color. But somehow I have to press on it so it works. Huh. Okay. So the circuit works also with 12 volt, it works fine. Now I have to think about the LEDs. I don't want them to be on all the time. I want it to be off. So we also seen that when it's not driving, when the LED is on, it is in high impedance mode. That's okay. We will have default. We will have. Well, but that's good actually. Is it? Maybe I can do it with only one MOSFET instead of two MOSFETs. I don't want to invert the signal because it's good that if it's sleeping, I want it to be switched off. And we could think that switching off is putting this into high impedance, putting this high, so you switch off the LED per default, because this is a common anode, so it switches the cathode low to put the to enable the LED. And we see that when it's using PWM, it's driving the circuit, so high to switch off, low to switch on, with 3.3 volts this time instead of 3 volts. But when it is completely off, it is in high impedance mode, because when I touch the probes, we see in the oscilloscope that I inject some 50 Hertz signal. Or maybe it says that it is a 1 kilohertz signal. I can inject a signal. Now it's at 3 volts, but it should be sleeping. Did it detect a motion? Okay, if it's sleeping and if it's high while it is, if it's pulling while it is still on, it would be nice to have the LEDs, but I can't put the 3 volt LEDs, they will burn immediately. Okay, we know it works at 3.3 at 12 volts. Let's put the LED back, and I don't remember how it was connected. Let's put the LED back and see, because here the voltage is high on one and low on the other. Why is it high on the red one? So here there is light. The light should tell you that everything is off and you're still pulling high. Let's solder the LED back on. Switch this off, switch power supply off, switch it back to 4 volts. Up. And let's solder the LED back on, and I don't remember which one is the common anode. Let's use a multimeter and find out which one is the common anodes. Up. Multimeter into diode mode, and we just put at one end, and I know that this is the common anode. Yeah, minus, the one which is marked minus, is the common anode. Let's solder it back on here. And you're helping, you have to hold this while I'm soldering the LED back on. I will not put it through the holes, it's just a quick hack right now. So what I currently want to test is when it is sleeping, when the LEDs are not on. Is it in high impedance mode, or is it still driving the LEDs? Both should be possible. And let's test it out. This is plus. Let's put it this way so you can see what's happening. This is plus, and there are too many pins connected to minus. Let's have a new minus cable. Up. 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 That's minus. Let's put it to 4 volts. Voltage 4. And if we switch on. Okay, the blue LED is on. I don't know why. Okay, now I can measure if it's in high impedance mode or not. Why is the blue LED on? Okay, now everything is off. Is it in high impedance? No, it's not. Let's test the other channel. No, both are pulled high. So it's not high impedance while it's sleeping. While it's not sleeping, here. Now we are in mode where it's a fixed color. Here, this should be changing color now. No, it's only just blue. Is this changing color? Yes, this is now changing color. And the connection is really bad. Ah, this is because the small drop was because we had a bad connection and we had currents through the LED. Come on, blue. I'm not interested in you staying blue. Change the mode. Change the color. The button isn't working anymore. Now it is. And now it should be changing color. And we see the waveforms. But it's only changing the blue color, not the other ones. It is trying to, but the LEDs don't seem to work. Maybe the wrong values. There's only the blue LED works. Ah, because I soldered it wrong. I think, yeah, the minus was the common. Yeah, I soldered this thing wrong, the wrong way. But at least we know that here, when it's in high impedance, it is still driving high. So we cannot connect, we cannot put directly N-channel MOSFET, because if it's high, it will let the current pass. We could have a cascade of MOSFETs. We could have one which inverts the circuit. Oh, we could have a signal inverter. I don't think I have any inverters. What kind of logic ICs do I have? Let me check in my parts bin. Multiplexer, transceiver, translator. I have no idea where I put my logic. Here, logic. I have AND gate, OR gates, but no NOR gates. Cut 4 inputs. 4 input, no. 4 times 2 inputs, NOR gate. Or NAND gate. I should be able to use NAND, not AND. Can I use 2 NAND gates to form a NOT? Truth stable. So if we have 1, 1, so inputs 0, 1, 0, 1. If it's an AND gate, that's 0, that's 1, that's 0, that's 0. That's an AND gate. So if it's a NAND gate, not AND, it should be the other way around. 0, 1, it should be 1, 1, 1, 0. Can I use to invert it? Yes, I can use NAND gates to invert the signal. And I have 20 of them, so yeah, I could use NAND gate. I have also NOR gates. What was the truth table of NOR? That's AND, that's AND, that's OR, and that's NOR. So, in OR, this is, just no, yes, not OR. We could also use NOR gates actually to invert the signal. And in the IC book, IC. that's my book with IC logic, and here I should have NAND and NOR gates. Yeah, NOR gates, and we can use these ones. These are NOR gates. Oh, these are huge, but at least they're easy to solder. Do I have them? Small op amp, USB-C control. What else do I have? Translation. From where I should have other here, but they don't have as many inputs. Oh, this one I can't read anymore. What is this? MPN, I don't remember. Touchscreen control. Let me write it before it gets completely removed. And it's a touchscreen IC. That's C16936666. C169366. And how is it called? What's your name? No, it's just 223. Touch sensor. That's a touch sensor. So I have NAND gate with individual inputs, and I thought I had here. Here I have AND and OR gates. Oh, I had more of them. Here I have four times AND. I have more. So this was. I don't want AND gate. I want NAND gates. Here, NOR gates. I could use these ones, but I could also use NAND gates. So we have NAND gates and then OR gates. Okay, I have several of them. What do I? So let's use NAND gates, because NOR gates I already used 3 of them, and I didn't use any of the NAND gates. So we will use one of the NAND gates. We will add some output. Yeah, we will add some circuit. So we will build an additional circuit. We will connect to this one. Let me get my boards with the proto boards here. So in this box I have plenty of. So this is my project box with prototype boards, where we will build a prototype. Using, so probably I don't want to use an adapter. I can probably directly solder on the prototype board. Do I have a small part which remains? Because I don't need anything big, something like that. And I can solder directly everything on it. The pitch, let's see if the pitch is okay, else I'll use an adapter board. Don't want to, it would be a waste for this project. It could be a lot easier to just create some board and order it, but that's not the fun part we want. So here we have the AND gate, no, the NAND chip with 4 inputs. We only need 3 of them. I think when we don't use the other one, we have to tie up, because else it could use a lot of power when it switches all the time. But yep, I can't directly put them. I have to use an adapter. Nothing which is for this SOIC. Seriously? They're here. This is for sub only. Come on, adapter boards. And here we have more of these adapter boards, and I want one for sub 14, is it? 1, 2, 3, 4, 5, 6, 7, yeah, sub 14. This one is probably too small. Sub 16, T sub 16, sub 16. So we could use this one. We lose 2 pins, we don't care. These are adapter boards. This is sub 28. I think I have no sub 20. And I have to reorder a sub 16 adapter boards because I don't have any anymore. This is the last one I have. So we'll be able to put our NAND here. I don't have any NAND chip in SOIC in DIP format. I don't use DIP anymore. I don't use a lot of through-hole components anymore. So we will have this, which will be used as an inverter, and then we will have the 3 volts, 3.3 volts, which I burned my mat. We have we will have transistors which actually drive this MOSFETs, the LED tape. And I'll probably use AH1B, something like that, as transistor. How do we want to connect it? We want to connect through this. There will be 12 volt coming in here. So that's not ideal. Then we can have 12 volt going there, but we need another voltage regulator for our board, because this won't be able to work. Although, do we need another voltage regulator? This NAND gate, can it operate at 12 volts? And if it operates at 12 volts, so what's the reference for the NAND gate? Let's get the data sheet up. We are going to full screen. Here are the NAND gate. The reference is C19434. It won't find anything this way. NAND gates, yes. Just give me the data sheet. That's the thing. It's using PMOS and NMOS and 12 volts parametric rating. What's a parametric rating? I don't know what this is. Yeah. That's the package. What's VDD? Is it maybe the part which is different? So here, if we look at this device, does it tell the maximum voltage? Yeah, to 12 volts. So we could actually use it powering, but does it then work? What's the voltage input? If I provide 12 volts, we can operate the device, but can it still switch on and off? We don't need it. Here, the voltage inputs high when it is a voltage output. Here, voltage input high. If we are at 15 volts, it's 11 volts. Okay, so that won't work. Oh, if we're at 3 volts, the maximum. That's the maximum. And what is it? The minimum. We have minimum. Okay, so we cannot operate it at 12 volts because the input voltage for the threshold is 70%, something like that. Yes, 70%. Because here, if we have an input voltage of 10 volts, so an operating voltage of 10 volts, we need 7 volts at the input to be detected as a high. So we cannot power with 12 volts this NAND gate and then have signal levels at 3 volts because this will never be detected as high. We have to power it with 3 volts. And the minimum voltage is, I think it's 3 volts. What's the minimum voltage? Operating condition. Here, operating rate. 3 volts. Yeah, and we're at 3 volts, so it's fine. 3 volt would also have worked. But we need the 3 volts. Means that we will steal the 3 volts from the voltage regulator to power our device. That's okay. Can we put everything actually on this board? That would be nice if this board would have all the ramifications. We could solder some chips on the other side. It depends on the pinout. What is the pinout of this thing? Okay, VCC, VSS, and then there one which we don't need and the other which we need. And can we put the MOSFETs right there? Oh, it wouldn't be very, very beautiful, but it could work. It would save us some pins. It would save us some soldering task. Do I want to solder here and have the MOSFETs here? It would be easier to debug. It would take more space. And actually I could put this circuit inside here. Yes. So instead of having the battery, I would have this circuit, the 12 volts going in. And actually I can still use the LEDs and have the indication of the LED. Yes, I think it's instead of completely replacing this LED will be in parallel. Yes, we can cheat this way. This LED will still work, so it will indicate if everything is fine. And then we will have an output DC jack. But it only works. Yeah, that would work. With 3.3 volt, the LED work. Yes, it will work. And we could have a DC jack, which goes on the side or on the bottom. Not on the bottom because it will change this, but somewhere, probably on the case here, I will have a DC jack to plug the 12 volts, or on the side, I don't know yet. We'll find that out later. For now, let's solder this part, and then this part here. This will clean it a bit. Up, where are the cutters? Up. This is clean, and some solder work just because this is relaxing, so it is absolutely not worth the time I spend on it for a simple gadget, and it would be a lot easier to just use off-the-shelf parts. I still want to try to do it. Up. It's relaxing. Let me switch back the camera. Okay. Stack the opposite corners. Okay, and now let's drag solder. Solder. Oh no, this drag solder doesn't work on this one. The flex has gone too fast. Okay, the pins are soldered individually. We can have headers. We will put this in the center, so we have access to all sides. Probably the easiest. let's do it this way, and then we have space on the side. Header. Oh, I don't have a lot of headers. I need to order new ones. Should have sufficient for this project, but I'm getting short on headers. I still have plenty of... Actually, these ones should be sufficient. 1, 2... no, there's one not enough. It's lacking just one of them. So I can't use these ones. Up. 7. Oops. This is 6. That's 2. This hole is filled. This will not help for soldering. We could actually use this stream to answer questions about the last episode, but let me check. But the episode is not... There's no one watching, so I can't answer any questions. Actually, I could publish the video now. I should. What's the time? Yes, I will publish the video. I'm logged in, so I can't. So I can. So let's publish the video on YouTube. Did anyone try to watch my video? Let's try it here. No, no one seems to have used it. So, up my channel. I want to switch accounts. No, it's not the right account. Switch accounts. This one. Videos. No, my videos. Upload video. No. Let me check my videos. Unlisted. Edit. And let's make it public. Done. Save. Tack. Now it's public. So now you can see my video also on YouTube. Well, if you're subscribed, you should get notified. Up. Up. So that's the first part. Let's solder it in the middle. Somewhere here. Up. Oh, this is soldered. Let's cut the leads. But before I cut leads, let me put my protection goggles, because these things are nasty. Do we have some kind of tissue too? So it doesn't go too far away. Yep. Okay. Nothing in my eye. That's good. Okay, so we have this. We will cheat. We will have this LED powered by 3.3 volts, by this output here also, and this also by 3.3 volts. This will sit in here though. So let's put it, so this is in the center, this is how we will sit in the end, and we will have the MOSFETs on the side. So we want MOSFETs which are able to switch high loads, well, some kind of, the MOSFETs, where are my MOSFETs? LED, diode, extension, through hole, resistors, SMD. Huh? Didn't I put my MOSFET on a wheel? Thought I did. Like I didn't. But I have my MOSFET book. And here we should have, yeah. These are just low level signals. But I think this one, this SE20302DS, I think it's 2 amps, something like that. Let's test it. Let's verify if it's one of them. But they are fake. I wrote it somewhere here that the pinout is not the one which is commonly used. So yeah, MOSFETs, you always have to check the pinout on MOSFETs. It's never the same, and this bit me plenty of times. So normally one is gate, so gate, source, drain. And here we have source, gate, drain. Yeah, but I wanted to check. This is an NMOS, that's true, and it's rated for, it's not rated. Capability, what's the capability? 2.5 amps, yeah, that's fine for my lights. I don't think they use more than 1 amp. So we will use these MOSFETs, these internal MOSFETs, to drive the LEDs. The pinout, we will keep the pinout in mind, well, just next to us. And we actually don't even need resistors to pull up or down the signal, because it's hard connected to this device, so this will always be driven. We could add resistors on the gate between the output and the gate. That's a good measure. I think I'm too lazy, so I'll probably not do it. These gates should be able to cope with it. So what's the voltage input, what's the voltage output, what's the ground, and so on. We will have a 5-pin connection from here to the board. 5 is enough. The 3 with 3 volts, yes, we need, yes, we will need 5. Do I want single wires or do I connect? Oh, actually, I don't know the colors. We'll use single wires because we have pretty colors. See, we have our box of wires with 5 colors, and it's perfect for what we need. Actually, 5 is not sufficient. We have ground, 3 LEDs, that's 4, and then we have 12 volt and 3.3 volts, because this should be able to switch to 12 volts. Do we want to put one? Do we want to put a 12 volt connector on here? We could actually. That would make my life easy. Do I want a 12 volt connector directly here? I'm not sure. Do I want it on the board? Because if I put it on the board, it will be with this device, and I'll have to plug the 12 volt connector here. If I use one of these things, I could move it around how I like it. I don't know which one I will use. I'll probably go for this one. No, I don't care. I could use this one. So we could have the board, the power connector right here to connect the 12 volts. And we plug it on the side. Where is the front cover of this thing? This is the front cover with the lens. How do we want our connector? This will be in the back. Do we want it on the bottom? Do we want it on attached to the board? Can we? I think it's too high. If we attach it to the board, we cannot close the battery compartment because it will be too high. Yes, it will be too high. Except if we do it on the side, but on the side it's painful. Yeah, on the side it works. We want it on top, and that's far too high. We have the two. We could actually put it on the side, could we? Then we have access to the pins directly. Up. Will we cheat? How? If we cheat, how do we cheat? So, if we put this here, can we close it? No, we can't. So we won't be able to put it on the side. So the decision made, we will use one of these connectors. And it will be dangling on, I don't know if it's on the side, on the bottom. If it's on the side, on which side will it be? This will probably be this one, I bet, so on this side. So the input will be, but it will be on the bottom. I will make it on the bottom. And we will make it easily connectable, and to remove the, so we can easily add and move the connection. We will have a huge hole and then a connector so we can directly connect. So it's something like a PH connector. Ah, there are two connectors. We need one for the power and the other one for the LEDs, the LED strip. And for the LED strip, well, let me check what kind of connectors I have for my LED strip. I think I have a converter. Yes, which converts. So this is a normal pin header. Do I have these kind of things? I have this kind of header. Where is it? Yep, that's the header I also have, but the female version actually on my LED strip. But changing male to female is not that complicated. So LED strip SP. Do I have some of them? Not the right ones. I don't want to change it because it makes it here. Up. These ones, yes. I'll just use one of these connectors. So let's not make it. Let's make it just easy to remove, but yeah, we will use one of these, and then we have the pins. Where is it? We had male to female changer here. I don't have too many of them, so I need them. This is fixed, or is it the one which we used? No, we had one. Ah, it's here. Okay, let's not lose this thing. This will be important. Let's put it on our original controller. This was the original controller. Let's put it here so we don't lose it. It worked with this one. 2 amperes, and we have 2.8, 2.5 amperes, so we are fine. We will have to cheat for the LED. We will have to get the LED signal. This will be the output. The board will not be completely compatible. That's kind of a shame. Yeah, we'll have to modify the board so it uses 3.3 volt and not the voltage input. That's okay. That's okay. The LDO will... Oh, it will drop a lot of current because it will drop the 30 milliamperes for the 3.3 volt LEDs. So 60 milliamperes at 12 volts. This will be high current. Let's try it out if it actually works. If the LDO isn't getting too hot. If we provide 12 volt input and we are driving the LED. So, these are the these are the MOSFETs. Let's get the third one out. We'll have to cut the track here and connect this track to the 3.3 volt output. Let's get the cutter. Let's cut this track. So it doesn't use voltage input anymore. Okay. Then we'll have to solder a fine wire. So it uses the 3.3 volts regulated voltage. This will be not very efficient if we battery operated, because we will just spend the energy on the LEDs and they are less bright. They will be less bright, but they will still indicate, and it's fine. Up this. Okay, the LED should be the right way around. Let's verify if it is not connected. Up to so VCC is not connected. Let's test out. Yes, it is not connected. So we've cut the cable. So now we will have a red wire to connect up the 3.3 volts, which we can tap from here. It's not clean. Let's shorten the cable a tiny bit. Up. That's 3.3 volts. Up, and this will go to the LED over here. So, up. Power wire go here. Up 3.3 volts. Tweezers. Okay. Doesn't look too good, but it works. Let's put 12 volts on it, and let's test out. Let's put first 4 volts on it, and let's see if it works. Yes, there was the red LED, so it's a good sign. I already lost one of the MOSFETs. I only have 2 of them instead of 3. This connector we don't need anymore. We will not use this connector. Where is the box with the connectors? We will use one of these connectors, but I think this is already outside, so I don't need this anymore. Yeah, banana plug, barrel jack. These are the barrel jack connectors. You go in here. The tape on the LED to simulate darkness. Okay, we have red. Will it fade? And this seems like orange. It's very bright outside. Well, you can see it from the shadow. Berlin is very sunny the last days. Yeah, here we have orange. And it's drawing 20 milliamps. I think 20 milliamps is plenty fine for this microcontroller. It won't get hot. And even if we put it at 12 volts, it probably have no issues driving that. So let's put it to 9 volts and let's see if it works. 9 volts, still 20 milliamps. It's not getting warm. Let's put it to 12 volts. So right now it's dissipating 8 volts times 20 milliamps. $160 milliwatts. 1 watt. no, 10 volts. Okay, it's drawing 160 milliwatts. Yeah, and it can dissipate 160 milliwatts without issues. It's not getting warm. So we can use it this way, even with 12 volts. And it looks also nice. Oh, no, it started again. Ah, just by removing my hand, the light was enough to reset the circuit. Yep. More 200 milliwatts. 200 milliwatts will be no issues to be dissipated by this LDO. It's really not. No, it's really not getting warm. That's fine. That works. That's a good sign. That's a good beginning. So we will have the voltage inputs. We will provide actually the voltage, and we can try to make pin connections. Is it using? Ah, it's not. I can't use springs. What a shame. I will need to use kind of a connector. It would be nice if this would have a battery form factor. This way I could just put it as a battery to have something to simulate a battery. It would be nice if I could connect here and here. These are the two pins, and then I provide directly the 12 volts here. But I don't know if any kind of spring or metal plates which could act as a battery. Poor battery simulation. Never tried that. Let's see. I have some springs, but they're probably too large. Screw. Where do I have the springs? It's not something I use every day. Here. I have a box with springs. Oh, I could actually have here. I have a box with plenty of springs, which I've collected, which I salvaged from lots of devices. Oh, these look nice. These could be, yeah, but I'll probably use something a bit smaller. Something like this, if I would have. It's too large. No, it's not too large. I could put a spring here, and I will have to put, some pins. Actually, I wanted to have the other side around, so it's easier. Up. Yeah, I could have the spring. It's still too large. Do I have a smaller, a finer spring? Yes, I do. This is all. Oh, this one. This one looks nice. Yeah. This could be a nice spring, which goes here, and then on the other side I have two pins. This way I have my 12 volts. Let's put the two pins. I had two pins here. I think I have to remove. Ah, here's the third MOSFET. 1, 2, 3. I have to remove. Okay, let's solder the two pins. You don't see anything. Yep. here just soldered the 2 pins, which will be the minus. Everything works fine. On the back, let's solder them too, so we have even more stability. Now they are soldered. Even more stability. Let's cut this thing under the table. And so this will be the minus. And here we will have the plus. Could also use 2 pins for that. Pin headers. Do I have some 2 loose pins which I could use? No, no 2 loose pins. Two pins. To how far do I have to put it? Up. This will be somewhere around here. They need to go here. Put on the table. Oh, wrong holes. One, 2. Let's remove the bottom. Let's cut the leads. Oh, it's super bright. It's almost hurting my eyes. Far too much sun. Ah, there are people who have seen the video since I've put it on YouTube. I see that people are working, are testing it. Let's check the video details. I want to view, sorry, I want to view the video. View on YouTube. Yeah, 5 views, and some people tried the ICID website. Not sure how much they used it, but some people used it. If I put it this way, will it fit? Actually, not sure if that will be strong enough to hold the thing together. Let's see. Actually, can I solder on this spring? Yeah, soldering on it works. I'm not saying what I'm soldering because I don't want to damage my SD mat. Come on, cool. Okay. Just remove this one. Let's remove this. Okay, this is how it looks like now. Is it solid enough? Yeah. Holds well enough. Let's cut the top. And these also, I probably don't need them. And let's try if it works. So up. Ah. No, I don't have enough. No, it's there. Ah. It's too far away. Too far away. I'll put it here so you can see what I'm doing, even if there's so much sunlight. Okay, that's one side. And that's the other side. Yeah, this sounds well enough. So, let's put it inside and see if it can work. Yeah, I've lost battery connection. So this will be our 12-volt connection. And we don't have to change the box. There we have it. And this is minus, right? This is minus, this is plus. And the output will come the cable. Let's test if it works. Can we will have the output. Yeah, this will be the 3.3 volt output. This will be the LED, and we will have this connection to. We'll have the ground. We have the 12 volts, so 4 wires would be enough. And I soldered the wrong one. This was, how was it put in here, this way. Was it? Yes, it was. There's one screw right there, and the LED is connected this way. And we want the 3 wires to also come down here. Will we use a connector? Probably will have to. Let's solder the original LED around. So 3 volts. Okay. What is the common anode? I think it will probably be this one. Let's try it out. Multimeter, one probe. Where's the other probe? Multimeter, here. You are not in diode mode. Now you're in diode mode. And no. Okay, maybe it's just that I don't see the light. Yes, it's this one. That's the common anode. So let's solder it back on. So the original LED is back on. Actually, can we use it? No, we can't. It's not. It's just a one-sided board. And it was. Oh. It was this way. Okay. This is how it was. This is negative. This, no, that's negative. This was connected here. This was connected there. And this is how it originally was. Was it? No, it wasn't through the cables. It's this way. So we will need all these 4 signals for our LED. So let's put a cable. Do I have 4 picked for 5 cables with 4 pins? Small ones preferably. Here I have a box with 1 times something cables and connectors. 1 type 3, 1 type 4, and I probably have some 1 type 4. They're not the right colors. It would be nice if there would be actually the right colors. Red, green, blue. But I probably won't have this cable. Let me go through my cable box up and see if I find a matching connector. 3 pin, we need something with 4 pins. Do we have something 4 pins with red, green, blue? and a small connector. This is 4 pins, but this is not a small connector. I want something. This is, wow, 8 pins. That's probably USB. How it's seeing how it's shielded. Oh, even some connectors with ferrite beads. Fancy connectors. Okay, nothing. We could make our own connector though. Yep, I think we will make our own connector. I have nothing with only 4 cables, which is small. Ah, this one maybe? Ah, that's 3. Something with 4 cables. That's 4, but it's not small. This is one, and I don't remember, one of these fan connectors. And these are packages, these are huge connectors. Do I want to use one of these? They're huge. Oh, I don't want to use one of these. Too huge. Too beaucoup. 2, 7, something like 6, 5. What's this? 5. It's not useful. I have nothing with 4 connectors, which is flat. We'll probably just make some Dupont header, which we plug this way around. But Dupont is also not small. Do I have something small? Oh, I have here. So, what kind of connectors do I have? We have HX connectors, PH connectors, and 8 micro JST connectors. These are too large. These are the ones I don't want to use. I don't have enough space to also hide the cable. I still want this to be reusable. These are also too large. These are the same, actually. Although here micro JST, but too many cables and I don't use them. And we have the HX connectors, and we have something with 4 pins, which is 90 degrees. 4 pins, 3 pins, 4 pins, but not 90 degrees. Come on. I have plenty of 3 pins, but not 90 degrees. I need 4. No, I don't have 4 pins 90 degrees. 5 pins 90 degrees. These could be fine. This could be okay. But yeah, I don't have with 90 degrees. Oh, do I need 90 degrees? What pitch is it? I don't remember the pitch of these connectors. Can I use a 90 degree header? And this should be sufficient. Let's check. Where are my 90 degrees Dupont headers? Here, these ones. So here we have 90 degree headers. Do we have something with 4 pins, something like that? Does it fit? Yeah. No, it doesn't. No, it doesn't. Wrong pitch. So let's not use this. We will use none of these connectors. We will probably just make a Dupont, a flat Dupont connector. So Dupont case, crimp, and this way we can have colorful wires. Actually, I could even use this kind of connectors. They're large though. Yeah. Let's make just a Dupont header. This will arrive here. And then the cable will come from the top. This will be how we will have our connector. Up. have even below. So, do I have Dupont? Something with 4 pins already with nice colors, so I don't have to crimp them myself. Yeah, but we don't have the right colors. Would be nice if there would be red, green and blue, and I don't. I hate crimping, but we'll have to crimp. At least they will be flexible this way. So, yeah, we will use these colorful cables. Very flexible, and they'll do the job. Let's try with red. Let's start with red. You will be holding my circuits. Which one is red? I think this is blue. Probes, in case these will come later on. So this is the common cathode. This is come on. Did I solder it? Yeah, I soldered it the wrong way. Red, green, blue, but I did solder it the wrong way. Although I tested it before, I don't know why I did solder the wrong way. Now this solder is getting super old and there's probably no flux inside anymore. Let's remove the existing solder, let's put new solder on it. Let's try again just to be sure. That should be red. Yeah. Red, green, and blue. We'll remove this red and we will have the plus not red but yellow, because red will be there for red will mean red LED. I have some red wire. So we have are you seeing what I'm soldering? No. This is red LED. And we'll have the red signal. Then we use yellow. yellow would be a 3 volt line. And it has to go to this pin before it goes below. Do I have somewhere else where I can tap the 3 volt, which is more elegant? No. So it will be this way. Okay, yellow is with 3 volts. There we have it. Then we have red, green and blue, so now we have green. Let's tin the wire and let's solder it. Green, that's soldered. Okay. Yep. And the last one is blue. Tin it. It's a bit too long. Up. That's... Oh, the other one is trying to get away. You have to stay there. Oh, I did something wrong. I switched green and blue. This is blue. This is green. Hup. Now we have our 3 colors. Up. This I don't need anymore. Up. Put it to the side. And now we will have our connector. So how long does it have to be? This will go. This will be somewhere on here. So it only has to go. I'll have to try it out. So let's try to put holes on this case, and for that I'm using a soldering iron with a garbage tip, so it's a large tip which is quite nice to cut through plastics. Okay, and yeah, this is fine. You see how useful it is to cut through plastics and to make holes to plastics. Up, and voila, we have a hole. Just need to clean it up because it leaves marks on the side using a cutter. And on this side too. There we have the hole for 4 cables. We can actually put this back in. This goes here. We put our 4 cables through the hole. One, two, three, and last one. You also go in here. 4. Up. Let's put this device. Psst. There is a second screw here, but it's not meant for this board. This board only works with one screw. This is weird. It probably was designed for another product. Yep, but we have. So we should have the 4 screws here. 1, 2, 3, 4. These are self-tappers, not meant to be used more than once. They'll do the job. Okay, so this still works. We'll solder plus and minus. That's minus. And that's plus. It used to be VCC. Oh, battery voltage for 5 volts, but now it will become also 12 volts. Here we have our cables, and we can try out if it works. Where's the black tape? Black tape on the LED to cover it. And on this board we will also put this. Where is it? Yep, this one. So minus is here. We'll have to add some. It's a bit too long. We'll make it shorter. Yep. Let's cut the wires, and I have to prepare the glue gun because this will be fixed, else it will break too fast. This is minus, so plus will be on the other side. Minus plus. Stay inside. Okay, looks ugly. Hope it just does the job. Okay, minus is connected. I wanted to use the desoldering gun to remove. This is too hot. I just damaged my probes. Okay. This soldering gun will keep it warm because I'm sure I'll use it again. And here, up hot glue. Hot glue takes forever to heat up. At least that we can up. So we switch to hot glue gun. Let's put it here. And here is a fan to cool off the glue. And it's this way around. Once we put it, let's first connect the what wire will we use for the 12 volts? Yellow again, but yellow is 3 to 3 volt, and we can't use the other ones because they're the colors. Nah, let's use red. Plenty of red wires. Didn't I have one red wire? Was there somewhere? So we don't need these boards anymore. Let's put them back here. And this thing, these are boards. I don't need the proto boards. So you go back in here. Too many things are around here. Winkelkatze, you go here. Now let me switch off the power. So I used to have a red wire. This is long enough. Is this long enough? It needs to go here and here. Yeah, it is long enough. So let's reuse this red wire. It's small, but it only needs to carry 20 milliamps, so that's perfectly fine. Heating gun. Stand. Up. One pin, and this goes here. Let's increase this. Switch off. I don't need the fan for now. Okay. 12 volts should be there. Now, if we put this inside, it will be this way around. The cable should be on the front, but for now it's on the back. No, it doesn't work on the back. Cable needs to be in front. Let's tape the cables on the top for now. So, minus and plus, and if I provide 12 volts and I cover this LED, it should work. And the 12 volts are the 12 volts from the fan, this one. This is the button, don't lose the button. This is the lens for the PIR sensor. Normally this should blink when it's on. Yes, it blinks, and it's even on all the time. And no, now it's off. And if I switch on, you should see the LED changing color. And it does that very smoothly. Probably hard to see. No, it's visible. It's better visible, but that works with the 12 volts. So this circuit seems to be a good start. Switch off. Let's cut the case. Oh, let's glue. The hot glue gun is ready. Let's glue this cable in place because else it will never hold for long. Okay. This is now I need to have the fan on. Where is the fan connection? This is the fan connection. Switch on. That's not the fan connection. What's happening? 12 volts. Go to the fan. And you should switch on. Why aren't there 12 volts? Is the fan broken? Okay. A new issue. What's happening with you? Don't you have 12 volts? Multimeter. Switch on the multimeter. So you won't see the results on the screen because this multimeter is not connected. No, there are 12 volts. Here there are 12 volts. So here should be 12 volts. Why isn't the fan turning? Are there 12 volts here? No. Is this connection broken? There should be 12 volts here. No, there are not 12 volts. There was a loose contact somewhere. I don't know from which connector. Now it works. So now you cool the board down. That holds a tiny bit better. Let's put it up to the end. Okay. So that's one side. Up. And no, I didn't lose them. 1, 2, 3. There were 3 MOSFETs, although I have a new one. One has just been blown away. Yep. No, it's here. No, that's not one of them. No, I just lost one of the MOSFETs. Not too important. So we need 2 things. We need this connector for the input. Let's prepare it correctly. Up. Okay, a fan, I don't need you anymore. And here's the last of these 3 MOSFETs. I will use them again, I'm sure. I don't need this. So that will be our input. Actually, we can, no, I can't make it shorter. And we need a cable for the output, and that will be the 12-volt output. Can already solder it. Would it fit if we solder it this way? Well, do we have a tiny bit of margin on the height? Yeah, we have some height margin. I can solder the connector this way. The colors won't match in the beginning, not too important. 1, 2, 3, 4. Is this the same? Yeah, this is the standard. And the plus, yeah, it's nice also because we have the 12 volts, which are right there. So we can switch, heating gun off. No, not the soldering iron. The desoldering gun, we can switch it off. We can switch also off this oscilloscope because it's noisy. No, let's not switch it off. We will probably use it for debugging our circuit. One, two, three, and then the blue. Can also solder this connector. I'm not sure if this cable, this tiny red cable, is good enough. No, it's good enough. It's as thick as this one to carry the 2 amps. And the black one, although it is black, it is the 12 volt line. So let's connect it to the 12 volts. Okay, so this is connected to the 12 volts. Right? Yep. Yes, it is. And does it still fit? Nah, people are playing with the website. Not too many are playing with the website. I have to cut the case now. Yep, it's not working. So let's switch this soldering iron on and let's cut the case so we can have the cables going through them. No, it will hold. Here is the soldering iron to cut the case. This is warm enough, so it will be around here. This will be the first, and then all of this. I could actually use just a cutter for these parts. It's probably cleaner. But it works well with the soldering iron. And I just hope that this is solid enough. Yeah, this seems to be still solid enough. Okay, let's clean it up with the cutter. all 4 cables fit in here. Let's see afterwards. Actually, it's not a cutter, it's a knife. These 3 MOSFETs, I will lose them at some point. Let's put them here with the screw so we don't lose them again. We know we will use them afterwards. Okay, you will be here. And this will also be in the way all the time. So let's test if this works. Masterpiece, isn't it? Oh, not completely a masterpiece, but you're holding back. This okay. I have to pay a tiny bit of attention, but there we have it. And this will be here. This will kind of be in the way, but we'll just push on the thing. And now the problem is that this is in the way, and we don't have. Now ground is too far away. Should be this way. No, this way. Yep. But we have to cut a bit deeper on the white cable. But this seems to work. Up. Let's remove this for now, and this one. It'll just be in the way. So this was not even cleaned enough. Up. Okay. Does it fit? One. Seems to fit. Ta-da! And if we plug the 12 volts, we should still see the red LED going on and off. That works. Still, I didn't start at all the oh, this goes here. We didn't start at all the how is it called? The wiring and the controlling of the LEDs. But we have our circuit almost. Now we have to cut these cables and crimp them. Oh, they'll be very short, but we need to crimp them here. These cables. Crimping this will be a pain, crimping them here. But I want a connector. I have no idea. I think I have to remove the circuit. I won't be able to crimp it here. Space. So this goes also here. Up. Here we have the 4 cables. And we will use the same ordering. So sometimes you don't need to remove the stop. Depends on the crimp. On some crimps, no, I think you always do need to have the top, which is the cable itself. But sometimes, oh yeah, what I meant, sometimes, depending on the crimp tool you're using, the crimp doesn't pierce the cable, but it goes around the cable and holds tight the cable. It really depends. There are tons. Crimping is an art, and I'm not mastering at all. So we have 4 of these pin Dupont headers. They are far too long. I should have used something smaller, like the XT headers. But for now, let's use this. So 4 Dupont headers. Up. As crimping tool, I use this. It's iWiz 3220, and I'm really happy with it. I think I have around 7 crimping tools, and with this one I'm happy. There's also the version for hands made, to be crimped for handmade crimping, but this one, so which doesn't force, where you have to press yourself, but this one I'm really happy with it. So what I mean is here, this crimping tool, try to focus on it, this crimping tool pierces the cable. Sometimes, depending on the crimping tool, you don't, and on the crimping header, you don't pierce the cable, you just go around it. At least on this one, when it pierces, I'm sure that there's some contact. Yeah, crimping is an art, and crimping tool costs a lot of money if you want to do it correctly. I'm not in the business of building cars where I'm liable for, although I've seen so many things in the car industry where they don't care, but normally they should have some kind of quality, and they could be liable if the crimping is not done well. I'm building on a device which costs less than $2, and I'm hacking on it for my own, so who cares? Last one, and then I can add the header, the Dupont case. And then we can test if it still works. Not seeing anything because I have to see what I'm doing. Okay, there we have it. There we have our 4 cables which now have a header. And now let's add a Dupont case. to it. Do I have one with 4? No, I have one with 3, but I don't have one with 4. So let's use a large one and make, oh, although there's some remainings here. This is a 4 remaining, perfect. So, here, Dupont case with 4 things, and let's put the cables in. We have red, then yellow, let's keep the same order as the LED, then green, and finally blue. And now we need to be able to slide it here as expected. This hole is not large enough, so let's make it larger. Can I do it with the cutter, or is it too quick? I can hurt myself. No, I need to cut it with the soldering iron. So let's make the hole larger. And that's fine. Let's wait until it cools and let's clean it up. Is it large enough? Ah, 1 millimeter is missing. It seems to be large enough. So it goes. Just need to clean it. Up. Now we can put this back. And there we have it. And normally we should be able to plug it here. Up, up, up. Isn't it beautiful? I should put a bit more space on the right, but else it seems to work. So you will cut a bit more on this side. Okay. Now I need to wire everything. I have tiny cables. Oh, let's see if this tiny cable start with VCC. We'll start with one channel And if one channel works as proof of concept, we can still do the other ones. So VCC will be the second pin. This will be VCC. Which pin is VCC? So let's get what's the footprint of this thing. So here we have the datasheet, and VCC is pin 14. Okay, just this one. This tool, cut, prepare. Let's tin the cable. And let's solder it. Right here. VCC is done. Next one must be ground. Ground pin is actually this one. This is a ground pin, and if VCC is 14, I expect 7 to be VSS. Yes, or ground. It is. Ground. I have bag of power wires, and I already have some silicon wires which I've used previously, which are almost prepared for it. Ground. There will be plenty of grounds actually. There will be plenty of grounds. Yeah, let's do this individually. This here, I'll make it this way. This will be ground. I need some side cutter. Up. Up. So, ground and VCC are connected. Well, the chip should work. Let's try with one channel. Let's try with. So this is 12. Okay, this is 12 volt. This is there. The next one, green. We can start with green actually. So what we need to do is have two on the gates. We need to tie the two entries because we only need one pin, and then we'll use the output pin. What is this one? Red. This will not be. This will probably be blue. We could use blue. Are these the two inputs? How does this work? So, yep. It's this way. So, that's pin 1, meaning these two. Okay, but these two are not together. What's the output? This is the output. These two are the inputs. Here we have two inputs, and then this is the output. Oh, let's try with this channel, which will be blue. So blue, we need to short these two inputs. These are the gate inputs, and we will connect it to the blue of this thing here. So now we should have an inverted signal right there on this output. This should be the output, and there we should have an inverted input, inverted output. So we can put the MOSFET right there, and the MOSFET is here. What is the pinout of the MOSFET? With this output, we need to drive the gate. Ideally, we would put a resistor so there's no gate ringing and so on. I don't care. We will not. I think this is powerful enough because this is a high. This is a MOSFET. The gate has a it has a little capacitance, but it has a capacitance. So if you don't limit the current, you might have some issues. We'll see. So if we put, can we put it this way? So this way, this is the gate, this is the source, this is the drain. Let's connect the gate to the output. Okay, the output is connected to the gate. The drain must be connected to the blue of this one, which is actually this wire. Here we have blue. Oh, let's in the blue wire. You are blue. Yep. This one is blue. And the blue should go to the drain. And the drain is the one on top, obviously. This is the drain. The one right here. That's the drain. So this is where the blue wire goes. And the source will be connected to ground. Will I be able to connect the drain to this pad? Yes, I will. Drain is done. And now we need a ground wire. Where is my black wire? I had a black silicon wire which I used, and I don't know where I put it. Here, there's one. There's a piece right there. So let's use this one. Okay. This is ground, and this will be connected to ground this way. Goes here, up. Let's get it here. And then we can try if blue works. Up. ground is connected. Let's try it out. So, LED tape. No, I will not use this. I will use this to power it. Oh, I hit the camera, sorry. I did hit the camera. Now it's a bit loose. Okay. I will use a cable which is here. This one for power supply with 2 banana plugs, and then this barrel jack connector, so we can limit the current. So when we have a short, there's nothing happening. Let's limit the current to 40 milliamps for now, because there should be nothing happening. If I connect it now, well, there's the issue that we don't have any 3.3 volts, but at least nothing should be happening. Okay. That's fine. Let's connect it to power first. And then let's connect the other cable. Power, see if it works. Oops. Power. Okay, this works. And let's connect this cable. Okay. Up. And now if we connect it, there should still be no short. Okay, there's no short. There will just a lot of power in the beginning. Let's try to switch on the blue. So up. Now we make it as if it would be dark. The LED is on. At some point it should become blue, and when it becomes blue we should have the signal here. For now we don't connect anything to the output, but afterwards we will connect. So this crimping tool can be removed. Afterwards it can be connected to the cable, and I think there we have blue, and we have no short. So for now we didn't make any stupid mistake with wiring the NAND gate and the MOSFET, but we don't know if it works, but at least it doesn't short anything and it doesn't break anything. Yeah, the blue here is clearly visible. So batteries go here. Now we connect the LED and see if blue works, and if it works then we won. And I expect it to not work. No design works at the beginning. Oh, there was some blue right there. 40 milliamps will not be enough. I have to increase. Let's put it to 1 amp. I don't know. Okay. But why doesn't it work anymore? Motion sensor? Because I removed it from the inside. Let me unzoom so you can see also the blue, the LED string. So we don't, we might need later, but for now we don't need the oscilloscope. So let's remove the probes. Make a bit of space on this workbench because it's getting very crowded. Okay, this is the box for the springs, which we don't need anymore. So you go back to your origin on my shelf. This one we also don't need anymore. Up, you go back with my other lighting stuff. And the fan probably will not need it anymore. Will we? Not sure. Let's put it on this No, we don't. We won't need it. Up. Okay. This we also don't need anymore, and the remote control we also don't need anymore. And the remote control, I'll keep the battery. No, okay. Let's leave the battery inside. So when I use it, it's there. So let's connect this again and let's try out if it works. Let's put on right the tools. This LED, we don't need anymore. LED, you go with the other LEDs. Up. Ah, better. Okay, there we have the 12 volts. Up. Red. It stays on, it means that it is not bright. Let's see if this blue turns on. Now we have some green components added to it, and in the end there will be blue. Yeah! And now there is blue. Our secret works. Is it visible on the no, it's not visible on the stream here. We have some blue. Oh, it draws 1 amp. Exactly 1 amp actually. Ah no, it draws more because we're low on the voltage. Let's see how much it draws because we have 2 amps max. So I'll put it at 2 amps. Now we see that it is getting lower. I have to wait for a cycle. Okay, that's 1 amp. 1.1 amp. You also see it normally. It broke again. Let me... It's this one, I don't know why it broke. You didn't see the dashboard anymore. Now you see it. 1.2 amps. Around that. And it's one for 1 channel, and the MOSFET is meant for 2 amps. Now it probably won't do it continuously because 2 amps is a lot of to cool down, and we don't have anything to cool down, but that seems okay. So our circuit works. We can do the same thing for the rest. Up. Let's disconnect this. Oh, this is a crappy barrel jack connector. And let's disconnect this, and let's do exactly the same for the others. We also need to tie the output of the one we will not use. We don't know which one we will not use. Let's use the second. Let's use this one on top. So what's the schematic? We have the outputs and then the 2 inputs. So this is the output. It's not ideal. We don't have a lot of space here. Let's use it on the other side. The cable will be longer, but I have more space. Tool. MOSFETs, where are you? Here. Pin out. So the gate is this. Yeah, it's a bit crowded. It's a bit crowded here. Let's use the other side. This is the gate, and the gate should be here. No, too crowded. Let's use this side. There's more space here. So this is pin 7, and pin 8, pin 6 is an input. So that's input, input. This is outputs. This one is the output. This will drive the gate. The gate is pin 2. Pin 2, okay. Pin 2. Yeah, we have it here. It's pin 2. So input, input, this is output, right? Input, input, output, yep. Some solder. These are so small. Do I have enough? Here. And we have huge pads. There should be plenty to cool it down. Oh, and actually we are not far from the ground, so that's good to make the cables. So that's the gate. Input, input, this is the output. Output. Right here. The two inputs need to be tied together. Okay. The gate is, the source is pin 1. Source is the ground. So we must connect it right there. This will go here. This goes here. Let's use one of these cables. Where is my stripping clamp? Let's tin it. Source is pin 1. It's this one, and it needs to go to this ground. Up, stripping wire stripper. Up. And we didn't decide the color yet, but don't have to. For now, we just switch it on. Okay. And the last one, which is here, we then have outputs, input, input. So again, pin 2 is the gates. I can put it right this way. So it's the outputs connected to the gates. Let's clean the tip of the soldering iron and let's connect source in the drain. Okay. I can zoom again a tiny bit so you see more about my circuit. And that's the source, yeah. The drain are the pins in the front, and this is where we will connect the colors. So we have green. Let's do with green for now. Green, we will use this one for green. Here we have to tie the two inputs. We would have done it anyway, but let's do it now. Here is tie the two inputs. And here we also need to tie the two inputs. It's a schematic for that, yeah. These are the two inputs, pin 13 and 12. And they are tied, and we must tie them to some voltage. Let's try them to VCC, which is just next to it. And this way they don't oscillate, because too much oscillation could generate noise or could use too much power and so on. So unused pins, input pins, should be tied to any kind of voltage. Okay, green, this is the gate. The gate, this is the output. No, this is the gate. This is the drain, right? Drain. And the drain goes to this one. Up. Drain. Up, up, up. That's green out. That's the outputs. Green. Okay, and next we need the input green, which is the, where does it go? Have yellow next, the one next to yellow. This is so cramped. This multimeter, I don't use it anymore. Let's put it away. Up, up. Up. It's this pin. Okay, that's green, and it must go to this input, and the cable is just long enough. And meaning that this one is red. Yeah, it is. And we will have two red. Okay. So green. We need to strip this. Up. You will go here. And now red. We have red here. Up. that's red, so that's the drain. And the drain needs to go to red, which is this one. So you go here below, and then we arrive here, and that's red. Up, up. Is it well soldered? Ah, not well enough. And when I mean not well enough, look at this quality of this soldering. If I don't say well enough, it's really shitty. Okay, now it's soldered. That's red, and let's have the last wire. Is this one long enough? It goes from, so these are the inputs, and no, it's not long enough. And we have other red wires. I want a silicone wire. Nope. You know, they are all PVC, and oh, here's silicone wire. Okay. This one. This is red input, and it needs to go to this pin right here. Up, up, up. And it's done. Now we can test the circuit with all 3 LEDs. Let's connect this. Let's connect ground. Let's connect 12 volts, at least in the battery. Let's connect this 12 volts, and for now we just go to 100 milliamp just in case we did something wrong, so it doesn't blow up. No, it doesn't blow up. So we can switch on, so switch off. Amps. Let's try until it does a cycle, a complete cycle. Where's the black masking tape for the diode? Okay. And now let's wait until it did a complete cycle, so we know that all 3 work. That's green color. And now we're getting blue, and nothing blew up. So let's set to 2 amps. Let's connect the LED strip. This made cling. And let's switch on. Red worked in the beginning. And it stays on. So you can, let me bring the LED strip. Now we're yellow, so this is red plus green. Makes yellow. But we're using 2 amperes actually. Yeah, well, 1 ampere per channel. Ah, you again don't see it. What's the stupid... Why does this thing work? Break. I should put it in a while loop. We actually don't need this anymore. Okay. Oh, there's something wrong. It cannot draw 2.3 amp. There is something wrong with the display. That's weird. Here it says 1.9. No, it's okay. That's weird. On my display, it doesn't always say the same value as you see it. But it works. It works perfectly. Now we have a PIR sensor and we just put it in the battery connector. Modified it a bit. We can still use the battery if we want to. This will be somehow in the way, but we can cut out the plastic so this won't be in the way if we need to. Else, it works perfectly. So we need to increase a bit the amps. Let's put it to 3 amps, so it never limits. But yeah. Finally, I will have some motion sensor with some nice fading. And this is a project which was on the queue since, I don't know, 4 months, something like that. Okay, this is not good. Why, when it's off, the red LED are, when it's off, the red LEDs should not be on. Is it really in high impedance mode then? Do I have to put resistors to pull them down? Let's try. Let's have a resistor. So it's not completely finished, damn it. Let's have a... No, let's have 100 ohm. Who cares? It's just... Let's use 22K, but 100K would be good. So 22K. If we put it between the red channel and ground, ground is this pin. Does it switch it off? Or is there a more complicated issue? Oh, it doesn't switch it off. Oh, actually something gets warm. Ah, yeah. And this gets warm, that's normal. The ground connection is not strong, so at exactly this point it gets warm. So, if we put between ground and red, no. So there's something wrong. I don't know what, but there's something wrong. Oh, the secret. Oh, something is getting really warm. Yeah, the red one. Well, because it was always on. It's not meant to be always... it's so warm that actually the glue is not holding anymore. Ah. Okay. So, hot glue again. but we had an issue. Normally the red one shouldn't be always on like this. What was happening? I have to probe the pins now to find out what is happening without having the LEDs connected, so we don't draw the 2 amps. And 12 volt will still be there. So it's not an issue that it's not pulled on. There's a problem in the circuit probably. We'll find it out. Okay, let's switch it on. Red works. So, well, the red LED. I think I know the issue. No, I don't. No, I don't. It's push-pull, so no, I don't. So, ground. This is ground. Let's try 5. Let's measure voltages. I don't need you anymore. Yeah, 3.3 volts. So this is high, meaning at the output it should be low. The output of the red is this one, I think. Is this? No, that's input. That's 3 volts. That's input. Oh, that's weird. Why is the second input not 3 volts? Oh, that's pin 1. No, that's not red. Which one is red? Which one is pin 1? And that's here, that is red. So, red, we don't have 3.3 volts. Why don't we? Because we don't have ground. Ground, and I want, do we have, no, yeah, I can use this. Up, this will be our ground. So we should have 3.3 volts here, yes, meaning that the input we should have, and red is this one, I think. So here we should have input, output. So no, there's still something wrong. Oh, 7 is VSS, that's normal. So here 3.3 volts, 3.3 volts, then here we should have 0 volts. So here red should be off, if this is red. Let's draw. Which pin uses what? I'm getting confused. So, we have the gates. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2 go in the NAND gates and go out of 3. 4 is the output of 5 and 6, is it? Yes. This is VSS. Then we have 8 and 9, which go to a gate and go out. Then we have VCC and 12, 13 go to the last gate and go out to 11. Yep, that's it. So which channel is what? Up. Red was the one which was badly soldered. Maybe this is an issue. No, it's not that badly soldered. Okay, so we have red, which is the output of this MOSFET, and this MOSFET, this is the drain. That's okay. And oh, I didn't connect the output to the to the gate of the MOSFET. Yep, so obviously it won't work. I don't even know how it could have worked. So now it should work. Now it shouldn't get too warm. So let's still put up some glue to this thing, and let's hope that this time it doesn't heat too much. And that it holds better. And yeah, the fan, I knew it. The fan, I needed to cool it down. Now I have to hold it for 5 minutes. So it cools down. Wait, I'll switch the microphone off so I can blow on it. Or I just remove the microphone. And I'm back. This is holding good enough, at least, so I can make the tests. Up, up, up. Well, they should not. Okay, so it warmed up because of something else. Let's switch off the power. Let's connect power. I don't need this power anymore. This cannot deliver more than 500 milliamps or something like that. You go back to your source. Up. You go here. So power is connected, and let's connect the LED strip. Where is here? Let's switch it on. Red, and when this should be off, this should also be off. Let's up. Yeah, so that's already a good sign. Let's switch it on and let's see if all the 3 colors work. And the color mesh, that's yellow, so this is red plus green. Now we have all 3 colors, which is kind of white. This is where it draws most currents, 2.4, 2.5. Okay, 2.5 is the maximum, and then it switches on the red parts. Now we have green and blue. This is why we have turquoise color. And now we have only green. Or only blue? No, this is green and blue. 1 amp. And also all three colors work. Now we have red and blue. And if I remove this, it's off. And is the board heating? Yes, the board is still heating a lot. But I think it will survive it. Well, we'll see with time. Oh, this is probably also because the glue gun wasn't finished. Wasn't completely cooled down. Do I have to put a heatsink? Well, it is switching 1 amp. That's a lot. But I have no place for heatsink. Not in this package. I will see. Well, for now, it is done. I don't want to continue on it. It is working. We'll see with time if it is enough or if it's melting and so on. I'll keep an eye on it. But for now, it's done. So let's switch power off. Let's switch this off. Let's put it back in the package. Let's see if it fits. Up, up, up. We have to remove this because we have to put the screw and the 2 metal brackets in. So this goes here. I didn't think about that here. We have to cut this open. Oh no, we don't. We do somehow. The button, for example, here. I forgot the button and the Fresnel lens. Oh, I'm not sure if it's, I think it is a Fresnel lens. I'm not sure if it really is. Up. The three screws. 1 screwdriver is here. 2. And 3. Up. Let's cut this so we can put the cable through. It's still easier to do with a soldering iron cut in plastic. It doesn't require a lot of force compared to now. Come on, stupid piece of plastic. Up. Now we fit the circuit in. One side, that's the plus, so this doesn't draw a lot of current, so this kind of flimsy cable is good enough. Also the ground, and let's put the two brackets. This goes, is it, no, this way, and this goes this way. And the cover, which is here, I can switch off the glue gun. It should be fine. Yep. Up the cover. Does it close? Nah, it doesn't completely close. Why doesn't it? It should. Huh. I lost the cover under the table. Up. So cover close. If it doesn't close, it's not because of me. Because of this weird plastic case. Well, it closes good enough. And let's try it out again. This, switch on. Yeah, works. We just set the red because if I... no, it's not... Oh, is it not dark enough? Yeah, well, the red worked, and now... Oh, the red doesn't work. Well, it has to draw. Okay, that's off. Now on. Yeah, it works. So that's it. Stream is closed. Finished. We had plenty of issues, and actually, no, now the USB is stable. But that's it for today. Whew. And I just have to install it in my bedroom, and we'll see if it works well enough. And this motion detector, so after 5 minutes it should switch off. So I don't expect it that there's too much problem with the current and that it heats too much. If there is, I'll let you know. I'll maybe make one other stream. But for now, this stream is closed, and yeah, enjoy this time with me, with anyone, or enjoy the video which I've released. Okay, see you for another stream at unknown point. Enjoy.